So, as you've seen, I started to rework the wiring on my N-gauge model railway so that I can install block detection and computer control. How hard can that be? So it's probably best if I start by talking you through some of the kit. Now the key thing I need for occupancy detection is this. This is a Digitrax DR4088 and it's part of their range of occupancy detection feedback devices. This one happens to be a Loconet version, which means down here it's got a couple of Loconet sockets, so I can hook it into my Loconet bus. But like all the rest of their DR4088 feedback devices, it's also got an S88N connector as well. So I can connect it to an S88N bus. Now I don't really know much about S88N, but this came in a starter pack which contained this, and it also contained this. Which is very similar to this one, but this one doesn't have the Loconet. This just has S88N in and out. And it also came with this wire, so I can connect this to there, this one into here, and this then means that I've got 16 blocks I can detect occupancy for with this bit of kit, another 16 with this, and I can still connect this into my Loconet, and the information for both of them, all 32 blocks, will be sent over the Loconet. So that's good. Let's just worry about this for now. Interestingly, this piece of cable it says on it, it's just a Cat5e cable, which is a standard sort of network cable. So one of the bits of testing I need to do once I've got some of this set up is to get any old network cable I've got lying around and make sure that that will join these two things together. The chances are I'll have a few more devices like this, or all in this range, and if I can use normal network cables just to connect them up, that will save me a bit of bother. I need to hook this into the Loconet though. Now I use a Digitrax controller, and so my Digitrax controller provides a link into the Loconet. So I'm going to use this piece of cable for that, or a similar one. This is a Loconet cable. It's similar to this network cable, but it's different. These network cables have 4 twisted pairs, therefore 8 connectors on the plug, whereas these have 6 conductors. They're not twisted together as far as I understand, and therefore there's 6 connectors on the plugs. It's possible to make these cables. I'll talk about that possibly in another video in the future. But obviously I can just plug that there into the Loconet and the other end into my controller. Now, so that's the various feedback buses which all connect on this end. If I turn it round on the other end, you'll see it's got a bunch of screw terminals. Now they're actually in 2 groups of 8, so there's 2 common terminals in the middle, one for the 8 on this side and one for the 8 on that side. And the idea is you hook this into typically your red wire running to your blocks, because it's DCC. There's no difference between red and black really, is it? Because it's alternating current anyway. You'd hook this across your red, so your red wire would come in here and then come out from one of these and go off to the rails. The black from the other rail doesn't need to come through here, it can just go straight to a common terminal. And this acts a bit like an ammeter. It measures the current that's passing through that red wire. And if there's any current passing through on more than a certain threshold, and I understand the threshold's pretty low, then it considers that there's something on that track block that's drawing current. Now, typically that's going to be a locomotive, or in fact it's going to be the decoder for a locomotive. But it could be something else. You could have a brake van with lights on. You could have a brake van that's just got a resistor soldered across the wheel set. And that can be useful because then the block or the system will know that the back end of the train is still on that block, even if the locomotive has moved off onto another block. So to get this going, I'm going to need to wire it into my Loconet. I don't think I need to worry about the other device just yet. I'll come on to that in a moment. But I need to hook it into my Loconet. And then I need to take some of the wiring for some of my blocks and pass them through here rather than going directly to the sort of main red terminal. There's a few other things I'm going to need before I can test it. The first is I've made a few mistakes with my wiring up my track blocks, and in particular I think there's a few places I should have put in insulated rail joiner and I haven't, so we'll have a look at that. I'll need to make some changes to the track. There's also something else on here that I need to deal with, and that's programming the addresses. Now, because this is the Loconet version, this has a little program button just here. And as I understand it, I can press that button and I can then use the controller, or use a throttle, to get the controller to send some accessory commands onto the Loconet. And this will pick those up and interpret them in order to program the feedback addresses. Now, just here, all these various connections, they're numbered from 1 to 16. But what I can do is I can tell the system that the first one of these isn't actually number 1, it's whatever number I give to it. And then all the others are numbered sequentially up from there. The other thing I can tell it is how many feedback blocks are being fed back. So this would obviously be up to 16. But if I connect some more of these on, it might be more than 16. If I hook this up, I could have up to 32. So I need to tell it how many devices I've got chained along the S88N bus. And I do that by sending a second command. So I can tell it the number of the first one, and the next thing I tell it is how many there are sequentially numbered up. So I think that's going to be the first thing I do. I think I'm going to hook it up to the Loconet and see if I can have a go at programming the addresses on here. After I've done that, I'll try and wire in one block, and then I can attach the computer and see if I can detect some feedback information and see whether it can tell whether I've got a locomotive on that track block or not. So I've attached this device to the Loconet, and you can see the light just there is flashing. So I'll get that to focus. The light just there is flashing over the regular flash. Right next to that button. So what I'm going to do is press the button and see what happens. And it's now flashing more rapidly, I think. Okay. So I'm now going to control an accessory, and it's going to be accessory number 1, I think. Okay. So that's now slowed down. Maybe I controlled it twice there by pressing the button. I think perhaps I need to start again. So let me try that again. I press the button, starts flashing more rapidly. I set it to accessory number 1. And now I do accessory number 16. Now just before I do that, you see it's now gone from the rapid flash to a slightly different rapid flash, I think. So now I'll give it accessory number 16. And it's gone back to a slow flash. So I think what that's done is that's told it that this device is controlling or is providing feedbacks 1 to 16. But I can figure that out by wiring in a piece of track. So after installing the DR4088 and a terminal block for all the black leads, then all I've got to do is just transfer across the red and black bus wires for each of the blocks. Here I'm just going to transfer across one so that I can do some testing. So I'll quickly show you what I've set up here. Here's my Digitrax controller, and you'll see this is the Loconet connection coming from it. I've just plugged in. That goes over here to the Digitrax PR4, which is the USB connection for the computer. And that's Loconet in. Loconet comes back out again and goes over to the Digikeijs DR4088. That's the feedback device. And then back here on the PR4, this is a USB cable coming off, going here into the computer. So I should be in a position to get some feedback information coming from the DR4088 and going into the computer. And as you've seen, I've wired in one of the blocks. So this is the main red feed going into the DR4088, and then this is one of the blocks. It's wired into terminal number 1, and that goes off to feed this piece of track here. And in fact, the block runs from the end here, it's all the way along this incline, all the way round to here, this point. And the insulator here causes a gap in the block. So what I'm going to do is run some tests by moving this locomotive around. There should be some feedback information coming whenever it moves across this join. So I'll set the camera up and run some screen capture software, and we'll give that a go. So you'll see the locomotive is not on the block. And what I'm going to do is run it in reverse, move it back onto the block, and as it passes onto the block, I expect to see some data on Digimon that'll indicate that it's moved onto the block. So put it in reverse first. There it goes. That data is the throttle commands. But now as it approaches the block, and there we go. I don't know what all that means, but that must mean it's on the block. If I run it back off the block, see what happens as it moves off the block. And there we go. Gosh, I don't know what all that means. All those B2s. B2 must mean it must be to do with that block. Try again. There you go. Well, that's really pleasing. That suggests that something's happening. Okay, well, I've got a slightly different setup now. I've got my train here on the track. Remember, the block that I've wired up starts about here. So at the moment, the train's not on the actual block. And I've wired up the computer. Got some slightly different software here. I'll put a screen grab up for this. So this software is Train Controller, and I have configured. I've laid out some of the track plan, and you'll see down here this bottom part of the track plan is got the block that I'm interested in, and I've called that block staging yard exit because it's the route out of the staging yard. So what I'm going to do is drive my train backwards onto the block. At the moment, the block's highlighted yellow, which I think means it's free, it's not occupied. And what I'm hoping is that it will turn red when the train goes onto the block. So let's have a look. So I'll put it in reverse, and let's see what happens. Just coming up to the block now, just off this point. There we go, and it's gone red. So that means that the loco is now drawing current from that block, which is going through the feedback device. The feedback device has sent a signal that's been picked up by the software to say that's occupied. Now, if I drive it off, it should clear again. I think it's off. There we go. It did take a little while. I didn't get it perfectly, but I suppose I did figure it out eventually. Not quite sure why that is. Back on. And off. Now that I've proved that I can detect a block, I need to take a look at the track that I've already laid and see how I've divided it up into blocks. I know I've made a few mistakes, so I'll show you what I've done. So, as we've already seen, this track here that leads to the incline, that's a one block, and we've tested that that works already, so that's good. And it's separated from this point by the insulated rail joiner just here, and that was installed because you need an insulated rail joiner to insulate this red rail from the frog, which will switch polarity depending on how the points are set. So that red rail is separate from the rest of the track. However, if we look at the diverging route on the point, this one here, there's an insulated rail joiner on what would be the black rail, and that's necessary to insulate it from the frog. But I also need an insulated rail joiner here to separate the red rail from the rest of the layout. I haven't put that in, and so that means that effectively this block continues onto these points. Now that's a problem because the software rather assumes that each block is in between points. It doesn't really work if you have a block that goes across points, and the way this is set up at the moment is this block here continues across these points, across the next points, and I've probably gone off the top of the screen there, but onto the equivalent track on the other side. So I think I'm going to have to just take out this piece of track and replace this rail joiner here with an insulated rail joiner. So that means two other things as well. It means that this block here will be separate from the one on the other side of the points that goes around on the inside. So that means they're going to be two extra block. There's going to be an extra block. So I need to separate the wiring, which I believe wires up. This rail is on the same bus as the one on the other side of the points. So I need to put in a new bus, and that will give me a new block. I also need to power the points, and the points need to be powered separately from the blocks. So when the train is on the points, when the locomotive is on the points, it's not drawing power from any of the blocks. I think that means that the software will lose track of the points, lose track of the locomotive while it goes over the points. But I don't think that's a problem, because I think it knows which way the points are set, and therefore it can work out on which block the train is going to reappear if it keeps going forwards or backwards, depending on where it last saw it. So I need to get to work, sort out those insulated rail joiners. I'll just talk about the rest of the track that I've laid. Now this section here leading up to the board joint, that's another block that runs all the way to the top of the incline. That's okay. Now obviously where there's a join across boards, there's a gap in the track, so that block ends there. So this will be another block, but again it then leads into points. So this block will just be this short little stub, leading up to the points, and I have got an insulated rail joiner there, so it will be separate from the points. This point work's all a bit complicated, and it does contain one or two straight stretches. That's the longest one there, but none of them are long enough to actually park a train on. I can't imagine I'd ever want to stop a train on that piece of track between those 2 points and run another train around it somehow. So what I'm going to do is consider all of this point work to be effectively one big point. It'll be separately powered from all the other blocks, and so a train coming in here will disappear from the awareness of the software. The software will know it's somewhere on all that point work, and as long as the points all stay the same and the train keeps going forward, it will eventually reappear over here on one of these sidings. Obviously each of those sidings will be a separate block, and it'll be able to detect it once it reappears. So I think that's probably it for this video. I've made some progress because I've figured out how I can detect blocks, and I know a bit more about what I need to do to lay track in the wiring in order to make it work. I hope you'll join me next time. I'm not quite sure what I'll be doing. I might be doing some work on the track, or if you're lucky, I might be playing around with some infrared proximity detectors to give me another way of detecting where the trains are on my layout.